Good morning, good afternoon, and good evening, everyone. Welcome to the webinar. My name is Ethan, and I'll be hosting the call today. As you all probably already know, we NXP have collaborated with our partners over at Crank Software to tell you how you can achieve exceptional graphics on your IoT devices with Crank Storyboard and NXP's i.MX Atm Nano applications processor. So, to begin, I'd like to introduce you to our speakers. To kick off the call from NXP, we have Amanda McGregor. She is a senior product manager at NXP. And following Amanda, we'll have Scott Snyder, who is a product marketing manager over at Crank Software. And then to wrap up the call, and we have Nick Schultz, who will be giving a demo today. And he is a field applications engineer also at Crank Software. So before I hand it off to Amanda, I do have a quick points. On the right-hand side of the GoToWebinar tool, you'll notice a question toolbar. Throughout the webinar, you are more than welcome to submit your questions via typing there. And at the end of the webinar, we'll have time for Q&A to go through the questions that you've submitted. If you look also in the handouts tab on the right-hand side there, we have also loaded the presentation material if you want to download it now and follow along. But we'll also be loading that to the community, the NXP community later, and sending out a follow-up email. And this webinar is recorded, so we will have that up as well afterwards. So with that said, I'll hand it off to Amanda.
Hello, good morning and good afternoon. Thanks everyone for joining. Amanda McGregor here. I'm a senior product manager for the i.MX applications processors. Today I'm going to give you an introduction, brief introduction to one of our newest quad-core application processors for the consumer and industrial space. The i.Atm family. So we recently launched the third member of the i.MX Atm family. It is the Atm Nano. This is continuing to build out our portfolio based on 14 FinFET technology and focusing on providing secure, connected, multimedia capable devices that can be used in many different consumer and IoT applications. Our strength across the Atm family is that we do have a roadmap. We have several products that some are pin compatible. They are software compatible across the family. So you'll see the same look and feel in terms of software, in terms of Linux, in terms of Android, and a lot of the same IP. The core complex is the same across the Atm Mini and the Atm Nano. And largely the peripheral set is the same. Of course, they all have their distinguishing features. If I focus in on the Atm Nano, we have two different versions available. The quad, in terms of a full-featured and a light version. And then we have 4-core, dual-core, and single-core Cortex-A53 offerings. We do have a very similar look and feel to the popular i.MX 6 series. So if you're looking to upgrade performance or features or move to newer memory types, this could be a great path for your next design. The Atm Nano is, as I mentioned, just launched, and it's built in 14 LPC FinFET technology. So it does allow us to provide faster operating speeds while also being more power efficient. The Atm Nano does implement up to 4 Cortex-A53s. We can run those up to a top speed of around 1.5 gigahertz per core. We include a separate Cortex-M7 for heterogeneous processing. It runs up to 750 megahertz, so we're really pushing some of the performance of the integrated MCU as well. And it can provide task offload for power optimization, security, and other functions that you want to isolate from the Cortex-A processor. And the Atm Nano does provide a scalability in terms of performance with its pin-compatible package to the Atm Mini, so you can scale up to the Atm Mini if you're looking for a more video-rich application. Or if you're looking to add more capabilities like PCI Express. We do have a very media-rich solution across the board for our Atm Nano applications processor. So it integrates a 3D GPU. And what we add here as part of kind of newer generations moving forward is the ability to run OpenCL code on the GPU, which is Open Compute Language, which can be used to accelerate ML algorithms. The GPU also supports the Vulkan and OpenGLES 3.1. So as you're looking towards future Android capabilities, driving a UI, those standards APIs become more important. The Nano can drive up to a single 1080p display using the MIPI DSi interface that can take in a camera, multi-megapixel camera support through the MIPI CSI. We have a variety of camera vendors that we work with that can provide solutions that pair with the Atm Nano. We have a single USB 2, we have up to gigabit Ethernet, single port with IEEE 1588 and AVB to help manage some time stamping for quality of service. And then we integrate a hardware asynchronous sample rate converter, which ensures that we can perform that capability in hardware without needing to dedicate one of the Cortex-A53 cores to that function. As with all of our Atm products, we do focus very closely on size and cost optimized system design. So during our product definition, we work very closely when defining our pin map, our package, our board layout to ensure that we provide the best possible system solution to our customers. We're delivering the Atm Nano package in a 14 by 14 millimeter size with a 0.5 millimeter pitch, which is a pretty fine pitch, but the way we've laid out the ball map, we do have a really nice depopulated array pattern underneath the package between the balls to give a 6-layer board design and no blind and buried vias. So we're able to deliver a small cost-efficient package while still providing a good system cost solution to our customers. Another big positive for the Atm family is we do support multiple memory types to give you more versatility for your system, whether you're looking for extreme low power with low power DDR4, whether you're looking for more PC style memory, DDR4 or DDR3L are other options that we provide as well. We pull away some of the need for external microphone interfacing, so we have direct connection of PDM microphones to the Atm Nano, and then NXP does provide board support packages for Linux and Android for all of our Atm family of products, and we do upgrade those on a continual basis to ensure we're delivering long-term supported kernels and the latest Android releases to you. Another key benefit of the Atm Nano is our industrial and commercial products that we offer. So we do have an industrial range of products which run from as low as -40 degrees Celsius to up to 105 degrees Celsius junction temperature, qualified for industrial operations. So think max operating speed, 10-year always on mission profile. We also offer a consumer version which can run the cores a little bit faster, give a little bit more performance, and with a narrower temperature range. And of course, the Atm Nano is on our 10-year longevity program on nxp.com, so you can be assured that we provide continued supply to you as you design this product in and go to market with your end product over the years. Okay, let's take a quick look inside the Atm Nano. Ethan's posted all of these slides, so you've got a lot of detail here in the block diagram. The key item to pull through here is just showing the display and the camera connectivity. We have a resource domain controller which allows you to map the peripherals between the Cortex-A or the Cortex-M. The way that they're partitioned is up to you, and they can, the core complexes can message to each other. And we have examples for how to do that in the SDKs that we release on nxp.com. We implement FreeRTOS on the Cortex-M core. We do support a variety of external memory, not just types, but vendors. So all of the big memory vendors we are working with, many we have validated with our reference hardware, and we also have Wi-Fi Bluetooth solutions available from NXP that will be enabled through our BSPs in the coming months. Some of the target applications here, by no means an exhaustive list, but just to give you an idea of where we're seeing traction with this type of product. So really very, very versatile. Either display-driven or headless applications are a great fit for the Atm Nano. We have a variety of different product SKUs. We have 4-core, 2-core, or single-core Cortex-A53s, and we have versions with and without the GPU acceleration. So if you don't need the 3D hardware, we have options, the light version that we can sell to you at a lower price. An example of an Atm Nano in a smart connected appliance. This is running Android. Not necessarily going through Android certification, but we see many customers looking to leverage Android, the framework, the security updates, the software updates that are already natively supported as part of the operating system. So we do see customers adopting Android for that purpose. And here is an example of, a small panel, up to 1080p, could be smaller, doesn't need to be 1080p. Driving a display with some basic graphics output to the display. And some of these devices are also Wi-Fi Bluetooth connected as well. So just giving an idea of how you can apply the Atm Nano to a commonly used device even in your home. We do provide full-featured EVKs to get you up and running fast with the Atm Nano. So here is a picture of our development kit, which is orderable from your favorite distributor, e-tailer, or directly from nxp.com. We do have, we are supporting DDR4 for this particular implementation, but we have low-power DDR4 reference schematics on nxp.com. We have all the reference files available for you to leverage in your design. And then we have pin compatibility with the Atm Mini. So you'll see in this example here, we actually use the same Atm Mini baseboard for the Atm Nano compute module. So again, just really kind of putting some strength around that pin compatibility story and how you can build hardware once and then tailor it to either a higher performing product or a lower performing product. Here's more details on the EVK. We do have add-on capabilities directly from NXP. We have cameras and displays. We have Linux 4.14, Android 9, and we're updating both of those in this year. And then we do have partners that provide additional camera capabilities. Here we have some embedded board partners if you're looking to use an embedded board solution, a SOM, system on module. We have a list of our lead partners. All of these partners here have designs available today with the Atm Nano. So for you, next steps to get started, on our website, we have full product documentation, ordering information, design files, software, PinMux tools, and we have a community for you to ask questions and receive answers to those questions. So please go and check out this website if you haven't already, and follow up on the community as you have questions. Okay.
Scott, you're next.
Perfect. Thank you, Ethan, and thank you, Amanda. So before we get started, I just have a quick poll question that we're just going to put up on the screen here in a moment. And the poll question is, have you ever used Crank Software Storyboard UI's development tool on a previous project? So the answer, of course, you can select from, or yes, I have, no, I haven't, but I am thinking about it, or no, this is the first time I've heard about Crank Software and I'm looking forward to learning more about it. So we'll leave this poll open for a little bit just to kind of gauge everybody's response.
All right, yes, and we'll leave it open for...
All right, looking pretty good. And we'll give it a close. So yeah, so I'm seeing about, you know, a scale of no, you haven't, but and then equally amount of people that say, this is the first time I've heard about Crank Software, and I'm looking to learn more about it and to how it can help me on my next one. So giving that, let me just select my presentation here, and hopefully everybody should be seeing my screen. And so let me get started. So definitely if this is the first time that you've heard about Crank and you haven't necessarily heard about us before, I can pretty much guarantee that at some point in time, either yourself or the customers that you support definitely have probably utilized a product that was running a UI that was built using Crank Storyboard. As you can see, we support a range of different verticals globally wise. So a little bit about who Crank Software is. Crank Software is a software and services-based company that is headquartered in Canada. Our leadership team has an extensive background in embedded graphics and systems with each of them over 20 years of experience in this field of developing and designing UIs. We have a large global customer footprint from Fortune 500 customers all the way down to small organizations, and we have hundreds of millions of devices that are out there in the field running a Crank-built UI. And then, of course, we offer our customers access to a global distribution partnership network, really providing them localized support. As I mentioned, we are a services-based company as well. So really, how can we help you? Definitely, if you have an idea that you need to maybe get buy-in from your executive team, we can really help develop UI prototypes in advance of the project to really kind of help you get that vision across so you get that buy-in. We can help build the UI for the device as well if you don't have in-house design experts or development teams, as well as maybe you have been using Storyboard and you're looking to maybe make sure that the performance has been optimized. We can provide you that and much more. So definitely, if you have a project and you're maybe at a particular hurdle, then definitely reach out to Crank Software and see how we can help you out with it. So let's kind of jump into developing UIs in today's market. What's really going on out there? So really, when it comes to developing UIs, things have changed. They've become increasingly more challenging. Definitely, user expectations have become a lot more elevated. It goes without saying that today's consumers expect an intuitive and modern kind of touch screen experience, so which not only kind of puts pressure on the hardware you select, but also on how you build that UI. And this is all thanks to the fact that each and every day we have this little powerful touchscreen device in our hands that really sets the user's expectations. And with that, the user experience has quickly become a defining part of today's product. So with it, UI being one of the main factors that products are being measured upon, and what often drives the perceived value the customers see in the product, and of course their purchasing decisions as well. So also integrating evolutions in technology no longer means simply making hardware decisions, but also how they can be incorporated into the user interface. And of course, anytime that you have lost time, so whether it's having to go back and recode or start over again, or resources are wasted, and like I said, coding changes occur, this all creates delays, and those delays can add up over time and really kind of delay the product from getting to market on time and on budget. It really goes without saying that given enough time and resources, we all have the ability probably to develop a product that exceeds all customer expectations and blows our competition out of the water. But unfortunately, when it comes to developing in the embedded space and developing our products in today's marketplace, there is never enough time or resources that are given. So how can Storyboard help? Well, Storyboard was designed to really remove the barriers that are typically associated with UI design and development. So Storyboard is our UI development tool, and it was based upon over 2 decades of experience in designing and implementing embedded UI solutions for a broad range of industries. So the founders set out to really kind of build a solution that they felt could help remove the inefficiencies that not only frustrated them, but their colleagues in the industry when it came to developing UIs for embedded devices. And so one of the unique things about Storyboard is that it decouples the front-end UI design from the back-end logic. So that way the designer and the developer can also work in this collaborative parallel workflow when it comes to building the app for the embedded device. Therefore, what it really does is it makes it possible for your project teams to really get started early on perfecting the UI, perfecting the user experience. Plus, it also allows your project teams to really, in your project, to embrace design iterations that naturally occur, and of course reduces the complexity of developing UI solutions in an ever-evolving field of embedded hardware. So in other words, what Storyboard does is really helps teams develop UIs for embedded products more efficiently, making it possible to get to market faster. So definitely, when we talk to our customers, powerfully simple yet sophisticated is what they often tell us when they describe Storyboard. Its easy to use interface and parallel workflow really makes it easier for them to get started quickly and more efficiently in developing UIs. And so things like, beginning the UI design process and familiar design tools such as Photoshop or Sketch, and then when ready, imported into Storyboard that creates the building blocks of the UI is one of the unique and great things about Storyboard. And then, of course, from there, the UI can be brought to life using Storyboard's integrated animation tools, allowing your project teams to create, edit, and review animations all directly within Storyboard. And of course, once the UI development begins, designers and developers can continue working in Storyboard's collaborative parallel workflow environment to really help remove the pain and struggle of managing iterations. Because it goes without saying, it's not a matter of if, it's a matter of when, because everybody has an opinion on how big a button should be, or where a button should be, or what a color should be, or the size of the font, etc. And so it really helps remove that pain when developing UIs for embedded projects. Also, what allows you to do is really go back and really fine-tune that UI, again, within the design tool, say like Photoshop, and re-import the Photoshop files without impacting the progress or causing a complete teardown of the code from the development standpoint. So it really makes, having to really fine-tune, like I said, that UI experience without having to create an entire new application or overwriting prior development work. Also, Storyboard offers up this really great, unique capability called Graphical Compare and Merge. And what it really does is it allows you and your teams to remain in control of those iterations by basically being able to, visually look at what the old UI looked like and what the change is, and selectively choose which ones you want to bring into the project. Also, Storyboard really provides the UI flexibility because it was created to be a platform-agnostic tool that enables you to de-risk your projects by introducing this agnostic framework that supports technology and design changes at any point in the development cycle, really allowing your UI flexibility in ways of scalability of going from an MCU to an microprocessor such as the i.MX Atm Nano. Also, it allows you portability of taking that UI and moving it from maybe one project to another, because maybe you have multiple lines and you want to have this consistent brand. So really allowing you to complete flexibility when it comes to the UI. So the thing about Storyboard is that we are not a code generation framework, which means that really lowers the barrier to entry. We use Lua Scripting as that that logical back end. So by decoupling the front end from the back end with that well-defined data model in between via APIs, it really provides that clean separation between UI development and hardware deployment, really helping the UIs become more resilient to design changes, as well as extensive development and testing has been done to ensure that the storyboard engine can take full advantage of the specific board features, such as proprietary graphics libraries or 2D or 3D functionality, or GPU acceleration and memory management functions without you having to worry about compiling and optimizing the code yourself. We've done the heavy lifting for you, which really helps speed things up, but also leverage those unique board features that really help drive your embedded performance. So when it comes to Storyboard and NXP, Storyboard's collaborative parallel workflow really enables faster iteration cycles. With some projects, it's been up to 50% faster and saving multitudes of time, allowing them to get to market faster. Like I said, it also scales up, scales down to fit the smallest hardware resources, or to support the rich set of features like the i.MX Atm family of processors, as well as Storyboard is part of the MCU Espresso SDK, really enabling for a more streamlined approach when it comes to evaluating the graphical performance of NXP's MCU product lines. Also, simplified deployment process. Like I said, those runtime engines have been optimized for you to provide peak performance on the end target, removing the need for compiling and cross-compiling that can really lead to time-consuming development cycles. And of course, we work closely with NXP to really leverage unique board features and graphical and memory management capabilities of their processors. For example, with the 7ULP and its 2D, 3D kind of GPU capabilities, we created a unique thing called hybrid rendering, which allows us to, get the rich value of 3D, but also the battery optimization or power savings of 2D, all within a single UI. So we work with NXP to really kind of bring these unique capabilities. But more importantly, when it comes to the i.MX 8, Crank Software and Storyboard supports the entire 8M family of processors, really enabling you to take advantage of the 8M's quad-core applications processor, or even the solo version to get rich 3D graphics, network connectivity, maybe embedded voice controls or camera inputs within the user interface. Furthermore, on cranksoftware.com, you'll find a range of demo images to really assist you with evaluating the graphical performance of the i.MX 8M processors, including a demo image that you'll find up there for the Atm Nano. So with that being said, I think we have a second poll question that we're going to put up on the screen here for you in a moment. Not seeing it on mine, but I'm seeing people do it. So what UI design features are you looking forward to using within your next embedded projects? Is it 3D graphics? Is it voice controls? Is it IoT connectivity? Maybe it's camera integration, or maybe it's smaller hardware design. And let's give the poll a little bit more. Seeing smaller hardware design come in, and definitely IoT connectivity leading the way right now, as well as rich 3D graphics. So keep it up for a couple more seconds. All right, and we'll close the poll off here. So definitely the majority of you are looking forward to taking advantage of things like IoT connectivity. The second one that definitely came up is the smaller hardware design, maybe allowing you to kind of put it into more embedded projects than ever. And so I wanted to kind of take the opportunity just to kind of talk about one of our customers that unfortunately we're not able to publicly talk about it at this moment because it's still in development, but I just want to kind of talk about, about the unique aspects that they were kind of really interested in. So to them, it was about two key aspects: secure connections for the connected world, and having design flexibility. So with multiple divisions within the organization, having different product lines that targeted different markets, they were able to provide this consistent brand image and experience across the different product lines. So what this did, Storyboard's decoupled architecture really helped them de-risk the embedded device projects by introducing that framework that I spoke about earlier to support technology or design changes at any point throughout their development cycle, because like I said, with multiple divisions, they were at all these different ranges into the development cycle and really providing that UI flexibility. So, when it came down to it, this included their interest in the i.MX 8 product lines that really provided them with the power and access to rich connections they were looking for, really for a well-balanced price point. This included being able to have devices connected to the internet for device management in the field, access to its robust GPU for the graphical and shader requirements, as well as the ability to connect camera devices for precise cooking. So there was a range of things that really made them interested in the NXP 8M product lines, as well as Storyboard. And like I said, if you haven't today, but definitely you're interested, definitely take a look at cranksoftware.com/resources/demo images for NXP. And like I said, you'll find a range of demo images there available for you, including one for the 8M Nano. And we also have a 30-day free trial available for you. It's a full feature. It's not reduced, really allowing you to get access to the full benefits of Storyboard. So that way, really allowing you to evaluate your next project. And the one thing that we're quite proud of is that you can get a demo prototype up and running in under 10 minutes from taking that PSD Photoshop file, introducing it into Storyboard, like I said, where it builds the building blocks for you of the UI, from doing maybe some quick animations, tying some events, and then to the testing and validation without actually having to deploy it on the target. You can do that all in under 10 minutes. But with that being said, this is a good opportunity for me to kind of hand things over to Nick Schultz, and he's going to actually give you a live demo of Storyboard right now.
All right. Well, thank you so much for the great introduction there, Scott, and thanks to Amanda for setting the stage on the NXP hardware product line. So I'm just going to quickly take over here and show my display. Perfect. So you all should be able to see the display here. And what I'm going to do is I'm just going to walk you through the process that we see with a lot of our customers. And one of the big reasons about why we bring value to the embedded graphics space is a big part of it is the process. And Scott talked a lot about it already. And he also mentioned rapid prototyping on hardware and validating. So the first thing that I want to do actually is before jumping into Storyboard, you can see the welcome screen here if you were to download our latest evaluation license. But I want to take you back one step into Photoshop. And that's usually not the only program, but one of the big programs where design really takes form and where your product starts to get a look and a feel and behavior to it. And this is where we bring value because we actually engage the design team in terms of how they can start creating assets to hand off to visual implementation. So you can see here we have a UI for a home control panel, and this sort of segues nicely into some of the applications that the 8M Nano is targeted for, where you might have larger than just a smart thermostat now, something that controls security, obviously the thermostat and other aspects, voice control in your connected household. So here we have a couple of different screens laid out in Photoshop. You can see we have our thermostat view. We also have a weather screen, settings for the home, general voice, security, things like that. And this is something where it's certainly not an exhaustive list of what you could do, but assuming this came from your design team and you're ready to start prototyping and iterating, you could take this file and import it directly into Photoshop and start playing around with it. So with that, I'm just going to go ahead, close Photoshop up for you. And jumping back to Storyboard, this is our free evaluation version, it is the full product. First time you open it up, you'll be greeted with this welcome screen. It's got links to some of our tutorials, documentation, our support channels. So it's a great way to kickstart your evaluation. And from there, our empty editor here, we can import a file directly from Photoshop. And you'll probably notice as I'm working around in the tool, there's multiple ways to go about doing things. You can import your Photoshop file from the model panel on the left or in the icon in the toolbar. I'll select that. And we have this wizard here, which simply allows us to navigate to the Photoshop file I just had open. And this is going to guide us through the process of either kicking off a new project, as Scott mentioned. You can also import into existing projects as you go. So maybe your design team is building up content screen by screen. You could select other options down here to import assets piecemeal as you receive them. In this case, it's our first import, so we're going to do a brand new project, and I'll hit finish. The tool right now is going through, it's slicing up all the assets you saw in the design file, and what you see here is it's actually exactly what we saw in Photoshop. So we have all of our screens. I believe there's 5 or 6 of them here, and you can start interacting with them in the design editor. The first thing I might want to do is maybe we'll set our main thermostat screen to be our home screen. Set that so it's the first screen you see when you launch your application. And from there, we can go and start adding some different implementation details. The first thing you might want to do is create some navigation between a couple different screens. And you can see at the bottom, we've got these elements for creating a navigation bar. You can actually go ahead and select them in the editor directly. Or on the left, if you open up, you can see your expanded diagram, which shows the application hierarchy. So one application can have one to many screens. Each screen can be made up of multiple layers, which in turn can have their own set of controls and content, so forth. But if we want to trigger off a behavior, in this case navigating different screens, we want to start off by binding an action to an event. And in Storyboard, everything is event-driven. And all that is to say is that we don't do anything unless there's an event to tell us to. And this is very important for the embedded space. One is that we don't do any rendering on the display if there's no events triggering different behaviors or redraws. So if your screen is static and you were to open up Top on the Linux terminal or other task management applications, maybe you're running an Android, you would see that we're not actively burning any CPU cycles. So as you scale your product line down, or you're using a single core perhaps and sharing between multiple processes, this is exceedingly important. All that being said, if we're looking to bind into this action and event discussion I just had there, you can see I right-clicked, add an action, and this is where we can go through and select our events to trigger different behaviors. In this case, I'm going to select a touch event. You can see here, it is not limited to simply user input events. We have hooks for the Android lifecycle for pause, resume, back button presses. Also, if your controls are gaining or losing focus, maybe you're using hardware key navigation and not using touch, we can support that as well. You can also go through and create your own custom events. So again, an event is just simply, as it is, an event, a notification, and then you can choose how you want to react to it. In this case, our action, I'll slide down the list here. We can select a screen transition. Fade, so you could fade in between screens. We also have some 3D accelerated ones as well if you wanted to do rotations or page flips. And simply select your destination. So in this case, we selected the thermostat button. So in this case, I'm going to navigate to the thermostat screen, which since we're on that screen, that might seem a little weird, but bear with me, you'll see where I'm going with this. You can also choose parameters, being duration, frame rate, easing, if you want it to be a linear, ease in, ease out, stuff like that. Hit finish. And I'm going to go ahead and do the same thing for the weather and settings buttons as well. You could select it, right-clicking on it, or you could actually take this, right-click, copy it, and paste it onto the other elements. you'll notice as I'm working, we're very big on doing things once and reusing behavior that's defined. So in this case, I've pasted the behavior, and I'm simply going to go ahead and I'm going to update the destination screen. Instead of thermostat, I'll select weather. We'll go ahead and do the same thing on the settings option. Right-click, paste. And we have a couple different settings screens. You could think of sort of settings having a bunch of subcategories. In this case, I'm going to select the security panel, just because it's interesting. And from there, hit save. One thing that I did here is I bound all of these action event bindings onto these buttons, but these buttons are part of a layer. And as I mentioned earlier, screens can be made up of one-to-many layers. But the nice thing about this is when you define content, in this case a layer, it's shared across all the other instances. So if I were to open up the weather panel here, you can see here we also have the menu layer shared with us. And it contains the same content. So if I were to scroll down and select our element in this layer, you'll be able to see that our touch actions are actually shared across all the instances of the layer. So again, I've set up this binding once, but it applies to all of our screens in this case. If I wanted to quickly validate, I can simulate our application. So you see here, I'm launching the application, and this is the same engine that's going to be running on the embedded system. It's simply built against, in my case, a Windows desktop. It's leveraging OpenGL. If I was running a Mac or a Linux desktop, the same thing would apply. But you know that my actions here, so you see we're fading between different screens, this same behavior is going to apply to the embedded system. So you're able to rapidly prototype and develop on your desktop before even having to touch hardware. Other elements I always like to call out, these buttons already have pre-existing touch events hooked up to them. That's because in the design file, you can go ahead and call out some of these elements. So we have naming conventions that further allow you to bootstrap aspects of your application. These plus and minus elements as well come into play here. So again, you're not sitting there building out your layout, defining your logic there, pushing images around in X and Y coordinates. You're adding behavior to your application. We want to go back up. There are other elements that we bring value in. Scott called out the ability for us to use the Lua scripting language, which is a powerful part of our embedded runtime. Lua is a very lightweight embeddable engine. It's very popular in the gaming industry where performance is always critical, as well as the embedded industry since it's got a very light footprint. It's also a higher level scripting language, so depending on where the skill sets of your team lie, you can hand off the UI development to people that might have more of a design background or perhaps web app development. They don't need to be embedded C engineers to develop this rich interactive UI. As you'll see here, perhaps we wanted to update this value on the thermostat screen. For every time the user hit the plus or minus buttons, we could increment or decrement this value. Right now, it's simply text on the screen, but I can actually go ahead and bind what's called a storyboard variable to that. And this variable is something that if we update it, whether it comes from a animation or in Lua script, any references that are attached to it will also update. So if you see here in the right panel, my text field is static text, but this angled braces plus icon allows me to create this dynamic binding to it. I'll create this variable at the application level because there's another screen I'd like to see reference this value. A new variable, I'll give it a name, call it temperature, finish. And now you can see the variable has text bound to it. And I'm actually going to go down to the weather screen as well and just bind our value on the weather screen to that variable as well to illustrate the concept. Obviously, you might want different values for internal and external temperatures, but for now, you can see how you can set something once and have a many-to-one binding relationship to it. The final step, and bear with me, I'll just write a couple lines of Lua script, is if we take this icon or this button on the right and hook up some logic to increment that value. So if I were to right-click and say add an action, user touch event, scroll down our action list, select a Lua script callback, and I'll give it a name, so CB temp up, finish. And we can have the tool pre-create that script file and callback for us. Yes. This is going to open up an empty function stub. This callback is where we can do some programmatic glue logic. So in a real application, real thermostat, it might be that when you hit the press, the up button, you send an event to a machine control to say, increase the house temperature, and you get an event from a temperature sensor saying whether the temperature is updated or not. In this case, I'm just going to fake it out in script. So we'll just hold that value here. But we can do some really quick logic. So just temp equals temp plus 1. And then we can push that value back into the UI. So if you remember, we created that variable. And we can just grab that path. In this case, it's temperature. It's at the global application level. So we can call it out directly in script. But we can push that back in with a function call. So we can set the value, and this function call takes a key value pair, the key being our variable we want to update, and our value being the new temperature we've incremented in Lua, temp. The last thing I might want to do is I'll just copy this degree symbol for formatting purposes, and since Lua is not a statically typed language, it can handle the type conversion for me. It'll convert from a number to a concatenated string. If I hit save, jump back to our application, simulate this. See here now, I can increment the value, and you can see how easy it would be to hook up the other behavior, or even hook this up into a real machine system where you have the ability to create your own custom events for temperature up or sensor updates, and then send them to and from external processes using a technology we call Storyboard IO. But for now, we've prototyped a lot of the UI out. We want to see what that looks like running on embedded hardware. So I'm going to go ahead and close that. We actually have a i.MX Atm Nano running with us. I'll go ahead and enable my webcam here, so hopefully you guys can see what we have. Perfect. You can see my reflection in there as well, but here's our developer board and the display. I also have a terminal open up to our development kit. So if you're curious, we offer a FTP deploy. So if I run ifconfig, we can see we have the Ethernet address right there. And this is running off of our stock demo image available on the website. After I launch this demo, I'll show you what the standard demo image looks like. But within the configurations view at the top, we can choose our export configurations. And in here, we can export, we have a couple different options. The GAP or GAP, as it might be called, is for embedded Linux or embedded QNX system. You can see we also have an Android export or an embedded resource header for the RT executive packages, such like a FreeRTOS or a i.MX RT 1050 system. Keep that. And then I also have pre-filled out our SDP transfer. So that's our IP address, authentication to the demo image, and then we can execute a script after we deploy to automatically launch our application. So I'll go ahead and I'll run that. And this is just exporting our app, so it's generating the GApp file from this model. It's exporting, and I also have a couple projects here, so it's exporting everything down here. But one thing I forgot to do is I may not have splayed off other versions of Storyboard. So you can kill off other versions before it's running, and we'll give that another go. But when we export over SCP, what's happening is we're going to deploy the project, and it seems like I'm having a bit of a network connectivity issue here, unfortunately, so I apologize for that. But when that happens, you have the ability to test and run on the spot. Not sure why that's happening, but what I'll do in the meantime is I will go ahead and launch our demo applications that you can see here. And what should be running on the embedded board will be what happens when you automatically boot. I'm having some technical difficulties there. Apologize for that. But what would happen is you would then be able to integrate and test everything out. So I'm just going to quickly reboot the board. But in the meantime, while I bring this system back up, I'm going to quickly switch to slides there from a call to action point of view. And then once the board's up and running again, I'll display what I was trying to accomplish there. So a couple key takeaways. We really encourage you to play around and play around with the system. Try the demo, so download that. And then from there, also download the demo image for the i.MX Atm Nano. And that allows you to iterate and develop and deploy on the embedded hardware. So again, we are quite keen for you to play around. The tooling and software is not limited in any way. It's simply a time license. And we want you to play around and test. And while I'm rebooting the board, this is where I'm going to open it up to any questions. And I might hand control back over to Scott and Ethan from NXP. And then once we're ready to go, I'll switch the webcam back on.
Great, thanks, Nick. We do have a few questions, so I'll quickly go through some of them. And for those online, you may have noticed that Amanda did answer some questions already via text, so you can run through those. But I will, let's see. Okay, so Nick, this is probably one for you. How do you port Crank software to the i.MX RT1060 and i.MX RT1064?
Great question. So what we do is we actually have direct integration into the MCU Expresso SDK, as Scott mentioned earlier, and that provides a FreeRTOS project with some sample Hello World applications that you can use to get running. And that's configured with the light variant, which is optimized for small memory footprint devices. And from there, we actually offer the ability to export the application that you build in your tool and then link it into your FreeRTOS project. So when I was showing you the export configurations on my display, there was an option for embedded resource header, so you export everything into that resource header and link it in. We also have a set of runtime libraries that are built against the FreeRTOS MCU Expresso GCC compiler, and we can run there. We also support other tools like IAR or other operating systems like MQX or ThreadX. So we're certainly not limited to that configuration as well. It's always important. Oh, go ahead.
Well, I was going to say, and not to take away from the Atm Nano, but if you are interested, there is an on-demand webinar that we did with NXP on the MCU Expresso that you can access on cranksoftware.com, as well as Nick put together some videos on how to do the entire process of accessing the SDK, putting Crank into it, and all that kind of good stuff.
All right. Does Storyboard support imports from other graphical tools such as Sketch?
Yes, so we do have support for Sketch import. Photoshop is something we've done historically. Sketch is a little bit different because it's a Mac-only tool, so we actually developed a plugin that allows you to export a file that you can import directly into Photoshop. So the workflow is slightly different, but again, the same end result is you can get your graphics into the tool and iterate and play around with them. We've also had other customers asking about things like Adobe Xd or Figma, and there are paths to get those content or assets into Storyboard as well. So again, the nice thing is, whatever tool you're using to get your assets into a UI development framework, we can support that. We also have some customers that have just raw asset packs from designers that either coming from historical projects or existing UIs that we can help support there as well. So, you know, we're fairly flexible in that regard.
Cool. Can you export to Android Studio?
So we don't export applications to Android Studio. What we do from the Storyboard tooling solution is we'll generate an APK file, and our application will run as a native application internally. So our embedded engine is running around and within the NDK. And what's happening there is it behaves as its own process, but is packaged in the APK framework. And you can modify the manifest and include external libraries and dependencies like that, but it wouldn't export out to the Android Studio toolkit.
All right.
And I actually just have the system up and running again, so I just want to quickly flip on the webcam again. Just had to read the system, but
Sure.
You can see here I've got the SCP console, and we have our touch input events happening there. Also some screen transitions as well. So again, you know, this is a 800 by 480 application. You can see it's running sort of centered there, but you could support up to full 1080p on this platform. And we allow the ability to resize applications and redeploy as well.
Great. I'm glad you were able to get that up, Nick.
Yeah, unfortunately.
Yeah, so we've got several more questions. All right, so does Storyboard include any of its own gadgets, or does everything start with Photoshop?
So we actually get that question a lot. As Scott alluded to, we're not a code compilation framework that you might see with a lot of other tools. We're also not a widget framework. So we provide a series of primitives, what we call render extensions, that give the ability to import images, text, different shapes, so rectangles, rounded rects, circles, arcs, things like that. But then you build up your content from there. We believe that, you know, it takes you longer to reskin and repurpose a canned widget or component than it might take you to rebuild exactly what you're trying to do. So if you were to look at our application on the board here, the settings screen, you know, everything is quite tailored to the experience you're looking for, the buttons, the presses, and all that. But once you've built that up, we have the ability to compartmentalize it into what we call a component. And from there, the components can be shared between projects. They can have their own animations baked into them and genericized, if you will. So I imagine if you're coming from a different history or tooling solution, that it might seem like you're not starting out with some of those pieces, but very quickly you end up building up your own library of assets and components. And the speed at which you can build your own tailored UI elements, we firmly believe is much more powerful and faster than starting with something and having to bend it to your will.
All right. Another one for you, Nick. Do I need to have a GPU to run Storyboard? I'm thinking of running on the i.MX Atm Nano Lite devices.
Certainly not. We offer different runtime configurations that leverage the hardware capabilities that you see on the different configurations. So as Amanda mentioned in her slides, there are different variants without a GPU, or in the case of the i.MX 7 ULP, 3D capabilities or 2D. We have renderers that can leverage OpenGL or purely software-driven rendering. If you even look at the RT series, so the i.MX RT 1050 or 1060, they have 2D acceleration in the form of a PXP chip. So we offer pure software rendering, which you can do there, and that's something that works standard across the i.MX 8 line. Or in the case of something that has some 2D acceleration, we can leverage that as well. You know, we work very closely with our partners and hardware vendors to ensure that our solution is optimized for the embedded platform.
All right, and I think we have time for one more question. Let's see. Can this be used on, and this I think is referring to Crank Software, can this be used on bare metal system, for example, without any OS?
Yeah, so whenever the comment to bare metal comes up, there's always a little bit of a discussion as to what you're doing and trying to accomplish. But in the case of the real-time executives, so I'll say the FreeRTOS or ThreadX or bare metal, we require a few minimum things. So one is the ability to dynamically allocate and free memory, so a heap 3 memory style configuration. The other is we need to be able to create a task, assign some priority to it, and then also have some synchronization primitives around that. So mutexes or semaphores. And then finally, we need to be able to create a timer. So timers can allow you to drive animations or do some interesting behavior at specific intervals. So those are generally the bare minimum. So we work with a lot of customers that may not be running a full RTOS but have their own OS abstraction layer. It's usually just a simple matter of porting to their layer and making sure those dependencies are in place.
Awesome. And Nick, there are several other good questions here that we weren't able to get to. So what I might do is I'll send them over to you, and we can follow up with them offline. Yeah, but with that said, I want to end this webinar. Thanks everyone for joining, and we will see you next time.
Perfect. Thank you so much.
Thank you. Bye.